Hello, fourth graders. Today we are doing Unit 3, Lesson 3. But before we do that, I wanted to just remind you that in the last couple videos, we talked about the place value sections method and the expanded notation method. And we're going to be using both of those today with more problems and talking about, how these strategies can lead to the same answer, but they're both how you find the quotient to these division problems. So let's start right here. 2-digit and 4-digit quotients. What's a quotient again? The quotient is the answer to a multiplication problem, right? So it's the one that's on the top. That's your quotient. The one inside the house is your number that's getting divided, so it's your dividend. And the number that's on the side is your divisor. It's the one acting and dividing things up. Okay, so number 1 is partially done for us. They have the place value above and the sections below. And then they said, okay, how many 10s do you need to multiply 9 by to get close to but not over 25? 3 10s would be 20, so like 250, 25 10s. 3 10s would be 27 10s, that's too many, so we went with 2 10s, which got us 180, and then we found the difference, we brought it over, then we asked ourselves how many 1s we multiplied by 8 to get close to but not over 72, and it was 8, right? And so it's 72, and there's no remainder on this one, so it's 28. We're going to do the same thing, but in the expanded notation model. So same question, how many 10s do you need to multiply by 9 to get close to but not over 25? 2 10s. Now this is important. We're putting our 20 there and we're lining up our place value, right? And so we're going to get 180 here. And then we'll subtract, find that difference. 7, a little ungrouping there, right? 15. Okay, and then you ask yourself, okay, how many 1s do I need to multiply by 9 to get close to but not over 72? And that is 8. And then it is 72 minus 72, and that's 0. So your answer is 8. Okay, let's try it here. How many 10s do you need to multiply by 6 to get close to or not over 162? You might be wondering, how come we're not even dealing with hundreds? Well, even 100 multiplied by 6 would be 600, and this number isn't bigger than 600, so it wouldn't, like, it's 0 hundreds, so you could write 0 hundreds. But, I mean, it's kind of a waste of time at that point. So, how many 10s? 1 10 is 60. 2 10s is 120. 3 10s is 180. So, let's do the 2 10s for 120. Find that difference. 2, 40, no hundreds. Bring it over. 42. Now the question is, how many 1s do you multiply by 6 to get 72? It's 7, right? And that is 42. And then you have 0. So then your answer is 27. Let's try it over here. 6 times 20 is 120. Difference is 42. 6 times 7 is 42. And then is 27. That's not so bad, right? All right, let's look over here. And now we're doing number 3. 8,984 divided by 8. Now the reason we're including thousands here is because, why? What do you think? If it's even 1,000 times 8, 8,900 is bigger, right? So it's at least 1,000, right? So we're going to say, well, really 2,000s would be 16,000. So we're just going to stick with that 1,000, and that gives us 8,000. And then we'll find that difference. 8, 9, 984. 9, 4. How many hundreds do you multiply by 8 to get close to but not over 984? 100 would be 800. 200 would be 1600. That's too big, so just 100. 800. And then we have 4, 8, 100. Bring that over. Oopsie, 184. It's very carefully copy these numbers correctly, because then your whole problem will be wrong. So you have to really be paying attention. 184. How many 10s do you multiply by 8 to get close to but not over 184? 1 10 is 80. 2 10s is 160. That's pretty close. 3 10s would be 240. That's too high. So 2 10s, 160. 4, 2, no hundreds, 24. Now, how many 1s do you multiply by 8 to get close to but not over 24? 3. 24. 0 remainder. So 1,000, 123. Oh, look, 1, 2, 3. How fun is that? Okay, now same thing over here. Same problem, just different flavor to it. 1,000 gives us 8,000. So that's 984. 100, 800, 184. 2 10s, 20. So 160. And then 24. 3. No remainder. So 1,000. We'll just leave that answer right there because it's already a pretty full page. Okay, I'm going to scooch my book over this way so my head isn't blocking it. How about I do this? How about that? There we go. Okay. So let's see. Give this one a shot on your own. You know, I've done these two with you. Try this one, hit pause, and then play when you're ready. Okay, now I'm assuming you're ready and you've done this already. Okay, how many thousands do you multiply by 3 to get close to but not over 7,000? 1 would be 3,000. You know, 2 would be 6,000. That's pretty close. 3 would be 9,000. That's too high. So 2 thousands gets us 6,000. Then we're going to find that difference. 1,722. 1,722. Now, how many hundreds do we multiply by 3 to get close to but not over 1,700? I'm thinking maybe 5, because 3 times 5 is 15, so 3 times 500 is 1,500. If I do 4, that'll be 2,000, also known as 2,000. So let's do 500, and then it's 1,500. Find that difference. 2, 2, 2. Ooh, 2, 2, 2. Have fun. And then how many 10s do we multiply by 3 to get close to but not over 222? That's like 22 10s. So let's think. What's that math fact that's 3 times something is 21? You remember what it is? It's 7, right? So 7 10s gets us 21 10s. And then we just have 2, 1, 12. And then 3 times what gets us 12? 4. So same thing over here. So 2,000 gets us 6,000. And then we subtract 2, 2, 7, 1. And then 500 gets us that 1,500. And then 2, 2, 2. And then 70 gets us the 21 10s. And then 12. And then 4 gets us the 12, 0. So what do you call 2,574? Well, 2,574. Hopefully you got that right. All right, let's go ahead and turn this page over. Well, we'll start like this. Okay. This finding group size. An orchard has 516 apples ready for delivery. There are the same number of apples in each of 4 crates. So we know the number of groups, right? It's 4. How many apples are in each crate? So we're trying to figure out the number of apples in each group. So we're figuring out the size of the group, right? So here's our little equation. 516 divided by 4 equals. And then you have your 4 groups. And now you're trying to put the apples in there. Now, technically, if you had all the time in the world, you could put 1 apple in each crate until you got to 516. But who has time for that? Not me. So we're going to divide the 500, the 110, and the 6 ones equally among 4 groups. So we're going to go through these steps together. So just stick with me on this one, okay? Step 1. You put 100 in each. So 500 divided by 4. There's 1 in each so far. And then there's 100 left over, right? That one that's kind of sticking out. And then we're going to regroup that 100 into 10 tens. And there's already 1 10, so now we have 11 tens. And that's why there's 11 tens in that tens place. Because we're bringing this one down. Okay, that's important. And we'll get some practice over here. So then step 2, we have 11 tens. That's the original 110 and that 10 tens of that leftover 100 that, couldn't easily be divided. So 11 tens divided by 4, each group gets 2 tens. There are 3 left, right? So this is the same so far, except we did 4 times 2 and we got that 8, and then we put the 2 up there for the 2 tens, and then we have 3 as the difference, and then we're gonna regroup that 31s and 6 ones, and we're bringing this 6 down to join where those 31s are, because now we're dealing with the ones. Then we have 36 ones divided by 4. There are, that's evenly 9, right? So then we have our 9 up here, and there's no difference. So there are 129 apples in each crate. Oh, we should have written on the lines too. So 10 tens plus 1 10 is 11 tens. Sorry about that. Each group gets 2 tens. 3 tens are left. And then that 3 tens is turned into this 31s, because that's the same thing, right? So then we have 36 ones. And then there are no ones left after we do the even distribution of the 36 into the 4 crates. Okay, so our answer was 129. And if you think about it, 129 4 times, well, 100 4 times is 400. 25 4 times, which is a little bit less than 29, is another 100, right? And then that's 500. And then that last 4 times 4 is 16. So 516. It makes sense, right? We're going to practice, and then I'm going to encourage you to do some of these on your own. And we're going to do this strategy. Now, if you really love the other strategies, you can use them, but this is, it's best to try this because this is how most people know to do division. So if your parents are helping you, this is the one they probably have down pat. So 800 divided by 4. What is that? 2. And then 200 times 4 is 800. Wait, I don't want to be messing this up for you. Oh yeah, we just put the 8. so then 0. So ignore that. Then we do, this is a little bit different this time. Then we have 4 times how many to get 6? Well, you can have 1, 4, and then you have, sorry. Let me start this over. I'm so sorry. Okay. So we put 2 up here. 4 times 2 is 8. Then there's nothing there. We bring this 6 down, and we have 6 tens. 4 goes into 6 how many times? Once. It's just 1 4. Then we find the difference, 2, joining. So now we have 28 ones. 28 ones. How many 4s are in 28 ones? 7. Okay. I know it's a little tricky, and the way that we're describing it is a little bit different than the way that I remember learning it. So I want to make sure I give you the right language. Okay, next one. Here we go. How many times does 6 go into 5,000? How many thousands would you get? Not one each, right? So we're going to move on, and we're going to go over and call it 5,100. How many 6s can you multiply by? How many hundreds can you multiply by 6 to get close to but not over 5,100? Let's do 8, and then we'll have 48 hundredths. We'll find that difference, which is 3. And then we'll have this 4 join us there, 34. 6 times what gets close to but not over 34? Well, that's got to be 5, right? Because that'll get us 30. And then our difference there is 4. Bring that 2 ones down. So now we have 42 ones. 6 times what is 42? Or close to but not over 42? 7. Right? Okay. Here we go. 3 goes into 4 how many times? 1. So it's just 3. Find the difference. It's 1. Bring the hundreds down here. Now we have 13 hundreds. 3 goes into 13 how many times? 4. That gets us 12. And then we have 1 left over. Bring that 9 down. 3 goes into 19 how many times? 6. That gets us 18. Then we have 1 left over there. Bring that 5 down. 15. 3 goes into 15 ones how many times? 5. Okay. Very nice. Now there's a song that I learned from another video that goes along with this so nicely, and I'll post it for my class, and I encourage other teachers to do the same. But basically it goes divide, multiply, and subtract, and bring it on down, and bring it on back. It's like really cute. I'll show you the video. All right, so 4 goes into 3 how many times? It doesn't. 4 goes into 33 how many times? 8. And that gets us 32. And then we have 1 left over, 1 10 left over. That's going to join these ones. And then 4 goes into 12 how many times? 3 times, and that's 12. Okay, number 10. 7 goes into 1 how many times? None, right? So then 7 goes into 16 hundreds. Like how many hundreds? You could do 2, and that'll get us 14. 7 times 2 is 14. Then we subtract, and we have 2 hundreds. It's going to join with these 10s, so now we have 21 tens. 7 goes into 21 how many times? 3. It's 21, right? Very nice. Now we have just 7 ones left to deal with. How many times does 7 go into 7? 7. Okay, next one. If you have 9 hundreds and you're evenly distributing it to 7 boxes, how many hundreds goes in each box? Well, 1. 7 times 1 is 7. The difference is 2. That's going to join with our 10. So now we have 23 tens. 7 goes into 23 how many times? It'll be 3, and that'll get us 21. And we have 2 left over for our difference, which will join our 9 ones. So now we have 29 ones. What do you multiply by 7 to get close to but not over 29? 4. And we'll get 28. And we'll have 1 left over, so we say 134, remainder 1. And I did that over there instead of on top because this problem had gotten so long. Okay. Number 12. Give this one a shot. Actually, give this whole row a shot. And then when you're done, check in with me and I'll go through them, okay? I'll change my marker color. So pause and play when you are ready. Okay, here we go. If you have 4,000 and 2 boxes, you can put 2,000 in each box, right? So we'll say 2 times 2 is 4. That takes care of all those 4,000s. 0. Then you have 2 hundreds. So you just need 1. So 1 times 2 is 2. So we'll bring that 2 down, and then we have our 2 there. Also 0. 7 is coming down, our 7 tens. So 2 times what gets us close to 7? 2 times 3 will get us 6, and then we'll have 1 left over. 1 10 left over. That's going to join our 6 ones, so it's 16. What do you multiply by 2 to get close to but not over 16? 8, and then it'll be 16. And then you have no remainders on this one. Okay. Next one, if you have 2,000 somethings and you're trying to put it in 6 boxes, how many thousands can you put in each box? Well, you can't put a full 1,000 in any of the boxes. So you're going to move over to look at your hundreds. How many hundreds? If you have 25 hundreds, well, you can put hundreds in each boxes. There's more than 1 for each. So then it's how many, right? 6 times 4 is 24. So 24 hundreds. We have 1 left over. That's going to be joined by our 7. So now we have 17. 6 times 3 is 18, right? But that's too high. So 6 times 2 is 12. And then we have 5 tens left over. That's going to join our 6 ones. And then that's going to get us, well, 6 times, there's not a clean math fact. I think we're going to have a remainder on this one. So 6 times what is 54? That's one of our math facts. Do you know what it is? 6 times 9, that's 54. You have 2 left over, so we say remainder 2. Okay, number 7. If you have 400 of something, can you put 100 in each of 7 boxes? No. So then you go over here and you look at your tens. 44 tens, you could put at least 1 of each of those in 7 boxes, right? So then we have, what times 7 is close to but not over 44? 6, right? That's 42. So now we have 42 tens. 2 tens left over, joining with our 1, so now we have 21. 7 times what is 21? Math fact, 3. Okay, after you've done these with me, now I want you to give these ones a try, pause and hit play when you're done with them. Okay, I'm assuming you're done with these ones now. I'm going to change my color pens. if you have 3,000 of something and 9 boxes, can you put any whole thousands in any of the boxes? No, there's just not enough. So we got to look at the hundreds. 3,700, that should do, right? That's more than 9. So we'll go ahead and we will think, what can we multiply by 9 to get close to but not over 37? I know there's math back for 36. Do you know what it is? It's 4, so 36 hundredths. So 100 left over, joined with our 3 tens, so now it's 13 tens. Now that's only going to be 1 9, right? So 9 tens there. And then our difference there will be 4, bring down our 5 ones. So now we have 45 ones. What do you multiply by 9 to get 45? 415 is our answer. Okay. Next one, here we go. 7, if you have 400 of something and 7 boxes, can you put a whole 100 in each of the boxes? No, you can only put a full 100 in 4 of the boxes, and then 3 would be empty. So we're not going to do it like that. We're going to move over to our tens place. We got 40 tens now. What can you multiply that gets close to but not over 47? So let's see. I'm thinking 7 times 5 is 35. So 5 tens, which the difference will be 5. Bring down that 6. What do you multiply by 7 to get, close to but not over 56? It's a math fact right there. Do you recognize it? You would if you practice your facts. It's 8. 56. And there's no difference, and so there's no remainder. Okay. Last one here. Let me scooch my book over. Go. You have 9,000 things and 3 boxes. Can you put a full 1,000 in each of the boxes? You do 1 round, then you'd have 6,000 left. You could do 2 rounds, and then you'd have 3,000 left. You could do 3 rounds. So yes, we can finally put something in the thousands place. 3,000. So 3 times 3,000 is 9,000. No difference there. We're going to bring our 900 down, and you know what? Same thing. It's another 3, so 300 minus 9 equals 0. Bring down the 5. Okay, so 5 here. We can only deal with one group of 3 tens, or one group of, yeah, so 0, 3, 2 is the difference, and bring down that 4. Now we have our 2 tens joining our 4 ones for 24 ones. 3 times what is 24? 8. And that's minus 24, 0. Okay. Here we go. Division word problems. What is the length of a rectangle with an area of 756 square centimeters and a width of 4 centimeters? So here we go. We have our picture representing the 756 on the inside, 4 over there. And basically this is kind of like a division problem for us, right? So I'm going to use my whiteboard because there's not a ton of space right here. Here's my pink pen. That one erases the nicest. So 756 divided by 4, because you know that if you have the length and the width, it'll multiply to the area, right? So we're trying to figure out one of those dimensions, so we'll divide, right? And it kind of almost looks the same too. So 4 goes into 7. How many times, if you have 700s, how many could you put in 4 boxes? Well, you could put at least 100 in each box. 2, not quite. So 4, that's 400, so 3 hundreds left over. Our 5 will join that. I know that 9 times 4 is 36, but that's too big. So let's do 9 times 8, or sorry, 4 times 8. And 4 times 8 is 32, which is 4 less than 36. And then we'll find our difference there. And hey, what do you know? That math fact from earlier was useful. What's 4 times what is 36? It's a 9. And there's no remainder. So we'll write over here. 756 divided by 4 equals 189 cm. Centimeters. All right, next problem. It says, at a county fair, there are 7 booths that sell raffle tickets. In one day, 4,592 tickets were sold. Each booth sold the same number of tickets. How many tickets did each booth sell? So there's 7 booths, and we're trying to figure out how many booths, or how many tickets each booth sold. So our number that's getting divided, our dividend is 4,592. And then our number of booths is right there, our divisor, and we're going to go ahead and work through that one. So if you have 4,000 of something, can you put 1 in each of 7 boxes? No, you can only put 4,000 and you'd be 3 boxes empty. So we're going to move over to our hundreds. 4,500. What do you think? What's a math fact that gets close to but not over 45 with a 7 multiplication? 6, right? 42. Minus that. Bring that 9 down. Okay, so that 9 is joining our hundreds is joining the 9. So it's 39 tens. Now what math fact gets us close to but not over 39 with a 7? We talked about it a moment ago. What about 5? That's 35, right? 7 times 5 is 35. And we have 4 left over. Bring that 2 ones down. Now we have 42 ones. Well, you multiply by 7 to get 42 ones. 6, right? And that's exactly what you needed, so there's no remainder. So we'll write that on our line. Whoops, just dropped my pen. 4,592 divided by 7 equals 656 tickets. Okay. Go ahead and give these 3 a shot on your own. See how you do. Hopefully you get them right. And then, so pause and hit play when you're ready, okay? One part of a city football stadium has 5,688 seats. The seats are arranged in 9 sections. Each section has the same number of seats. How many seats are in each section? So we have our dividend, the number getting divided, and then our divisor, the number of sections, and we're trying to figure out how many seats are in each section. Okay. If you have 5,000 of something and 9 boxes, can you put a full 1,000 in each box? No, you can put a full 1,000 in 5 boxes and then 4 are empty. So we'll move on to our hundreds. 9 times what gets us close to but not over 56? I'm thinking 6 because that's 54. And then we have 2 as our difference. So 2 hundreds will join with the 10. So now we have 28 tens. 9 times what gets close to but not over 28? That's got to be not 7, silly. I was thinking 27, so that's got to be 3. 27 minus 1. Bring down our 8 ones, so now we have 18 ones. 9 times what gets close to but not over 18? You know this one. It's 2, right? So 632, no remainder. Very nice. So 5,688 divided by 9 equals 632 seats, not tickets, seats. Okay. Number 21. An art museum has a total of 475 paintings hanging in 5 different viewing rooms. If each room has the same number of paintings, how many paintings are in each room? So 475 is our number of paintings that's divided into 5 rooms. From here, if you have 400 of something, could you put 100 in each of 5 boxes? No, you could not. So you got to go to the 47 tens, I should say. So 47, 5 times what gets close to but not over 47? Well, 5 times 90 would be 45. 5 times 9 tens is 45 tens. And then we'll have 2 tens left over. Bring that 5 ones down. So now we have 25 ones. 5 times what is 25 ones? 5. 5 times 5 is 25. That's one of my favorite facts. I just love my square numbers, you know. How cool are they? 475 divided by 5 equals 95 paintings. Alrighty. Number 22. A parking garage can hold a total of 762 cars. The same number of cars can park on each floor. There are 6 floors. How many cars can park on each floor? So if you have 700 of something and 6 boxes, can you put a whole 100 in each box? Yeah, you can. And then you have 1 left over, right? So 100 times 6 gets us 6, right? 6, so then 600, I should say. And then we have 100 left over. So then we bring our 6 tens down. Now we have 16 tens. What can you multiply that gets close to but not over 16? You do 2, and that gets us to 12. 4. Bring our 2 ones down. 2. Now that's a math fact there. What do you multiply by 6 to get 42? 7. 42. 0. So then our answer is 127. So we'll write out the equation. 762 divided by 6 equals 127 cars. And if you got those right, well, before you saw me do them, go ahead and give yourself a star or a smiley face or a little pat on the back or kiss your brain. Yeah, that's great. Next time, we're going to do a different sort of method, kind of similar to what we're doing today, but go and check and see if you have an assignment. Practice your math facts if you have time. Hopefully you do. It's so important. You can see how useful it is, right? And I'll catch you next time. Okay, bye-bye, everybody.